screen. So, you can see one thing, there are ciliary muscles, pupil, iris, aqueous humor, these are the areas we have seen. Optic nerve, the vitreous humor is the content inside the lens, inside the eyeball, okay, the ciliary muscles and retina, all right. And the next thing what you can see is, what is power of accommodation. So, now we listen here, come to this. So, here what I have said is, in the case of human eye, by adjusting the focal length of the lens, it is with the help of ciliary muscles, it is possible to get the image of objects at different distances, correct. So, this power of eye is what is called the power of accommodation. So, now how do you define power of accommodation? It is the ability of human eye to adjust the focal length of the lens using what? Using ciliary muscles, to adjust the focal length of the lens using ciliary muscles. What for it is to be adjusted? To see the objects far away and objects close to you. We need to adjust the focal length according to the object distances. That ability of eye is called power of accommodation. If you didn't have power of accommodation, what would have been the case? You would be able to see the object clearly only if the object is at a particular position. See the object always, if you want you to see to look at you, what is to happen? You should remain at a given position only, then only I can see you. Got it? So, but not like that in the real situation. So, why is it so? Because of the power of accommodation of the eyes, right. So, now again, first one I said power of accommodation, but listen, the thing is we see a lot of things every day, and the eye lens is contracting and it is expanding according to the position of the objects. We see the objects close to you, we see the objects far away from you. So, the ciliary muscles are continuously contracting and expanding. You might have heard of this one. It is very dangerous to sit in front of the computer or so for quite a long time, because it causes strain to your eyes. What is getting strained? The ciliary muscles, you can say. The ciliary muscles, the elasticity of the ciliary muscles will be lost. So, what happens? What we have to do, therefore, you might have heard of it, like you'll have to take a rest, you'll have to refresh after some time, then only you don't continuously use it. You close your eyes for a long time, otherwise when you are sitting in front of a computer, after a while you'll have to look at a large distance, both the extremes should be seen, then only your ciliary muscles are in a normal pattern. So that means we don't give pressure to the ciliary muscles. All right, what will happen? What will be the problem then? It will lose elasticity. You just see if you are if you say maybe a spring, okay, if you extend it and again compressing, a lot of time if you do, it will lose its elasticity, correct. So, if it loses the elasticity, the power of extending to that both the extremes will be gone. So, it will lose elasticity. So, that way ciliary muscles may lose elasticity. It usually happens due to aging. When you are aged, what will happen? You will have the ciliary muscles will be contracting, and the ability to contract and expand many times of ciliary muscle or both the extremes, it would be lost. What is this problem called? What is this defect of eye called? This is called presbyopia, right. What is presbyopia? Due to aging, the ciliary muscles will lose its elasticity, due to which you will not be able to adjust the focal length of the lens to that extent. So, due to which what can happen? You may not be able to see the objects very far from you, or you will not be able to see the objects close to you. Otherwise, if you want to read a book, you will have to read it like this, right, at a distance you will have to keep. Your near point is shifted further. What is the normal near point, or the what you call as least distance for distinct vision for a normal person? It is 25 centimeters, right. So, it will be more than that. You will have to keep the objects further from you, because the lens cannot reach up to that extent, because of the weakening of the ciliary muscles. Is that point clear? So, due to weakening of ciliary muscles, you may lose the elasticity, means you are not able to adjust the focal length of lens to both the extents. You will not be able to see the objects close to you, you will not be able to see the objects far from you. That means, you might have seen some people, they used to do like this, who is coming from a distance, that is all due to especially when you are aged, due to presbyopia. So, now let me ask you, what is presbyopia? It is one of the defects of eyes, right. So, it is the defect in which or by which a person cannot see the objects far away from you or cannot see the objects close to you as well. This happens due to the weakening of ciliary muscles, right. So, this usually occurs when you are aged. Now, you look at the screen, you can see what is the definition of power of accommodation. Accommodation is the ability of eye to change the focal length of its eye lens to see far away and closer objects clearly, right. And see, this is the case of the normal eye focus. You can see the light rays coming from infinity, the parallel light rays, they meet at the point on the retina. So, you will get the image on the retina, all right. So, this is the case of normal eye. Now, we will talk about certain other defects of eyes. Now, coming back to this one, look at the board. Okay. See, one point I have mentioned, in fact, two things I told you. I explained two aspects. Number one, what is the dissimilarity between the camera and eye, right. I had given an SMS question to you, that is what is the similarity between eye and camera, that you can find the answer and get back to me. Okay, so then along with that, I told you about the power of accommodation of eye, right. Power of accommodation is achieved with the help of what? Ciliary muscles. Then weakening of ciliary muscles leads to a problem. What is that problem called? Presbyopia. I hope it is clear, right. Now, let us think of something else. You know, this is the normal picture, that is the light ray is coming through this cornea and it is entering through the pupil, through the lens, and finally image is formed here on the retina, and that is transferred to the brain through the optic nerves. Okay. So, it is transferred to the optic nerves, all right. But again, if imagine, let me tell you certain situations. Okay. So, imagine the eyeball is not of the normal size, right, that is eyeball is bigger than what usually is. Then what happens is this lens will make the image, maybe the image will be formed where? In front of the retina. It will not be formed on the retina, it may be formed here, right.